Okay, general factoring strategy part D. Factor out. So when you're looking at a trinomial or a binomial or whatever it is you've got there, polynomial, more than three, always look to see, do all terms have something in common? And if they do, factor it out. It's going to make the rest of the factoring easier. Okay, always want to deal with the smaller versions. It's just a better outcome. That's the first thing you always want to do. When I look at anything, I say, do they have anything in common? The next thing you're going to look at is the number of terms in that polynomial. Is there two? If there's only two terms, you're going to check to see if it's the difference of two squares. Remember, the sum can't be factored. Or if it's the difference or sum of perfect cubes, of two cubes. You've got plans for that then. You can handle that. If there are three terms, well, is it perfect? Is it a perfect, trinomial? Or do you have to use the trial and error method? If there are more than three terms, you have to use grouping. It's just that's it. And then lastly, and this is something that students always forget, they think they pull out the greatest common factor and they factor and then booyah, we're done. Not necessarily. As you'll see, we've seen in the last video and you'll see in this video, you can factor further. So once you factored the first time, you factored out your greatest common factor, you factored out your binomial or trinomial, check to see, hey, is there anything in there that can still be factored? All right. If it's the sum or difference of two cubes, you're done. That's the only one you're done with. But everything else may be able to be factored further. Okay. So you need to check that as well. Remember, you can always check your factoring by multiplying through. I don't know very many students who like to check their work. So I'm going to say it, but there you go. All right. So looking at this first one, this is now time for you, since I've showed you all the concepts. This is now time for you. I don't know what that is. This is supposed to be a minus. To attempt these yourself, because I'm here to support you. Once you do your homework, you don't have me because you'd have to send me a message and none of you are doing that. So attempt each one of these yourself. Come back to see how you did. And that's it. And take notes. Let me know what questions you have. So pause the video. All right. These three terms have a couple things in common. They're all even, so they all can factor out of 2, but they all have y's. So we want to factor out our lowest y squared. When we do that, we have y squared left, plus 2 goes into 28 14 times, and we have a y left, so 2 plus 1 is 3, plus 2 goes into 98 49 times. Take 98 divided by 2. And then we already factored out the y squared. This trinomial has 2 perfect exterior numbers and variables. The y squared is a perfect square. The 49 is a perfect square. If you need to check it to see if it's a perfect square, you just take the square root. Second, x squared for this one. You got to find that little x square, that guy right there on your calculator. So second, x squared, where the x is, or the x squared is, to get your square root, and then type in 49. And you see that the perfect square is 7. So we can factor this into the sum of perfect square. Square root of the first, sine of the middle, square root of the last. There you go. All right. For this next one, pause the video, check for greatest common factor first, and then see what else you're left with to factor. And then come back to see how you did. So these three terms have 7 in common. They also have an x. So 7's gone. We're left with x squared minus 7 times 3 is 21. We're left with an x plus 7 times 2 is 14, and the x is factored. This can be factored further. Don't forget to bring down your 7x. So x and x, and this is just trial and error. I'm going to go with 2 and 1. That's all we can go with. The sign is only negative in the middle, so both have to be negative. To check yourself, check your OI. Check your outer two numbers and your inner two numbers. So we've got negative 1x, and the inner is negative 2x. This gives us negative 3x, which is what we have for our middle term. So this is my fully factored answer for that one. Pause the video and attempt this one yourself. This one has a 7 in common. Now we've got the difference of two squares. So x squared and x squared, plus and minus, 1 and 1. Square root of the first, both signs, square root of the last. We're not done. This is the difference of two squares. This is the sum of two squares. Remember, it cannot be factored. The difference of two squares. So you've got x and x, positive and negative, and then the square root of the 1 is 1 and 1. Now we are fully factored. Okay, 4 terms, we have to use grouping. Looking at the first 2 terms, what do they have in common? They've got a 4 and y squared. When you factor 4 from 12, you're left with 3. When we factor out the y squared, you're left with y plus 4 times 4 is 16, and the y squared is gone. Looking at the next 2 terms, we want to have the same binomial as we have over here. So to have that, because these are both negative, I need to factor out a negative 1 from this binomial, and that will leave me with 3y plus 4. You can check it by distributing that negative. Now from these 2 terms, we've got to factor out what they have in common, 3y plus 4. And we factor out 3y plus 4 from this term, we're left with 4y squared. Factor out 3y plus 4 from this term, you're left with negative 1. We're not done. Nothing can be done with this one. But for this term over here, this binomial, it is the difference of 2 squares. So 2y and 2y, 1 and 1, positive and negative. Now it is fully factored. Okay. It's only 3 terms. Find out what they have in common, factor that out, see what you have left, and go from there. Attempt this one yourself, and then come back to see how you did. They all have 3 in common. For x's, they all have x. The lowest one is x. For y, they all have y, so y is the lowest. When I factor 3xy from the first term, I'm left with 6. 3 times 6 is 18. X squared, y is gone. 57 divided by 3 is 19. I've got an x and a y plus 15, nope, 10. 10 times 3 is 30. And y squared. All right. For this one, I've got to understand that I could have 6 and 1 or 3 and 2. This is going to be trial and error for me. Okay. I'm going to try 3x and 2x. Everything's positive. Now for my 10, I know there's going to be y. For my 10, I've got 10 and 1. My factors are 10 and 1 or 5 and 2. I'm going to try the 5 and 2 first. So I'm going to put a 5 and a 2 and a 2 and a 5. Hopefully one of these works. And I need to check my OI. My outer 2 numbers need to be multiplied together. I'm trying these first. 3 times 2 is 6. And then my inner 2 numbers are 5 times 2 is 10. I have to add them. That is 16. That is not 19. So those don't work. Now I'm going to try my 2 and my 5. 3 times 5 is 15. 2 times 2 is 4. There it is. So 3xy, 3x plus 2y, 2x plus 5y. Oh, we didn't have to go to the 10 and the 1 or breaking down our 6, so that's fantastic. These do not factor any further, so we are good to go. All right, the next one is 2x to the 5th plus 128x squared. Looks like they've got a common factor, so do that first, see what you have left, and continue factoring. Come back to see how you did. They have a 2 in common, and they've got an x squared in common. Leaves you with x cubed plus 64. Well, that's it. All right, so this is the sum of 2 cubes. Cube root of x cubed is x. Cube root of 64 is 4. Square the first, multiply them together, square the last. Remember the cube, I'll get there. When you factor your cubes, this trinomial cannot be factored further. You're done. All right, looks like we have a practice down here. I will make a video for the practice problems and add that to it as well. When you do the practice problems, I want you to do the practice problems first, then watch the video to see how you did. This is the same thing you should do with your reviews. You should never come and just watch me lecture. That is not benefiting you. You're not getting a chance to get things wrong and then find your mistakes. You're just like, oh, this makes complete sense. And of course it does, because I'm doing all the work. You have to struggle through this before you go do your homework. I would advise you to do the practice problems, check yourself against me, and then go do your homework. Okay. Let me know what questions you have.